Welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It's Monday, the 27th of July, 2026. And tonight, the smallest headliner we've had in a while gets top billing.
That's right. Our lead is a world you cannot see without a decent telescope. One that half of the astronomy community will tell you isn't even a planet. And today is its brightest night of the year. Pluto reaches opposition. We're going to spend some proper time there. The discovery, the demotion that people are still arguing about, and the frozen world New Horizons actually found waiting for us.
Then, 3 quick stops. A crew comes home after 241 days in orbit. New modeling suggests the most common planet in the galaxy may be hiding oceans of molten rock. And astronomers have taken the famous first-ever black hole image and pulled a whole new layer of physics out of it.
And we'll close where we always do, under the sky, north and south, with a meteor shower that's putting on its best show for our Southern Hemisphere listeners. Let's get into it. So, Avery, set the scene for me. If someone walks out tonight and looks up, are they going to see Pluto?
Honestly, no. Not with their eyes and not with a pair of binoculars. Tonight, Pluto sits directly opposite the sun in our sky, over in the constellation Capricornus. That's what opposition means. Earth is passing between Pluto and the sun. So Pluto rises at sunset, sits highest around midnight, and it's fully lit and as close to us as it gets all year. A touch under 35 astronomical units, so roughly 35 times the Earth's sun distance.
And that's as good as it gets, and it's still faint.
Painfully faint. We're talking about magnitude 15. To put that in human terms, it's millions of times dimmer than the faintest star you can pick out on a dark night. You realistically need an 8-inch telescope and a good star chart. And even then, Pluto looks like a star. A dot that only gives itself away because it shifts position over a couple of nights.
Which is exactly how it was found in the first place. Let's rewind, because the Pluto story is one of the great underdog tales in astronomy. 1894, Percival Lowell, the same wealthy Bostonian who convinced himself Mars was covered in canals, sets up an observatory in Flagstaff, Arizona, and becomes obsessed with a planet X he was sure was tugging on the orbits of Uranus and Neptune.
And he never found it. He died in 1916 still hunting.
He did. The search went cold, then restarting, and in 1929, the job landed on a 23-year-old Kansas farm boy with no college degree named Clyde Tombaugh. His method was brutal, painstaking work. Photograph the same patch of sky on different nights, then flick between the two plates in a machine called a blink comparator, looking for the one dot out of hundreds of thousands that moved.
That is the definition of patience.
On the 18th of February, 1930, he found it. And here's a detail I love. The name didn't come from an astronomer. It came from an 11-year-old English schoolgirl, Venetia Burney, over breakfast. She suggested Pluto, the Roman god of the underworld, fitting for a cold, dark, distant world. And the first 2 letters, P and L, also happened to honor Percival Lowell. It stuck.
So for 76 years, Pluto is the 9th planet. It's on every classroom wall, every lunchbox, every mobile over a cot. Then 2006 happens.
Then 2006 happens. And this is the part people still get heated about. So let me try to be fair to both sides, because there genuinely are 2 good sides. The trouble started in the years before, when astronomers began finding other icy bodies out past Neptune in a region called the Kuiper Belt. And in 2005, a team found Eris, which at the time looked to be bigger than Pluto.
And that's the crunch. If Pluto's a planet, is Eris planet number 10? What about the next 20 objects we find out there?
Exactly the corner they were backed into. So in August 2006, the International Astronomical Union voted on a formal definition of planet for the first time. 3 rules. It has to orbit the sun, it has to be roundish under its own gravity, and, the killer, it has to have cleared its neighborhood of other debris. Pluto passes the first 2 easily, but it shares its zone with all that Kuiper Belt material, so it fails the third. Reclassified as a dwarf planet. It even got a minor planet catalog number, 134340.
A demotion with a filing number. Ouch. And not everyone accepted it.
Not at all. And this is the bit I want listeners to sit with, because it's not settled science, it's a definition, and definitions are choices. The loudest objection comes from planetary scientists, and Alan Stern, who leads the New Horizons mission, is the most prominent. Their argument is roughly, clearing the neighborhood is a strange test because it depends on where an object is, not what it is. Put Earth out at Pluto's distance, and Earth wouldn't clear that huge orbit either. They prefer a geophysical definition. If it's big enough for gravity to pull it round and it's not a star, it's a planet, full stop. By that logic, Pluto is a planet, and so are a dozen other round worlds.
And the counter-argument?
The dynamical camp, the folks who wrote the IAU rule, say a definition has to be useful, and anything round gives you potentially hundreds of planets, which tells you nothing about how the solar system is actually organized. Clearing your orbit captures something real. The 8 major planets are gravitationally dominant, and the Kuiper Belt objects simply aren't. So it's genuinely a values question. Do you classify by the object itself or by the role it plays in the system? Reasonable people land differently.
And then, as if the universe wanted to make everyone regret the timing, New Horizons shows up.
The best twist in the whole saga. The probe launched in January 2006, 7 months before the vote, so it left Earth as a mission to the 9th planet and arrived in July 2015 at a dwarf planet. And what it sent back demolished the idea that small and far means dull and dead.
This is my favorite part, because we expected a cratered, frozen billiard ball.
We got a stunningly complex, active world. There's a vast, bright plane of frozen nitrogen, Sputnik Plantina, that sits inside a giant heart-shaped feature the whole internet fell for. And that heart isn't static. The nitrogen ice is slowly churning, convecting like a lava lamp in ultra-slow motion, which is why it has almost no craters. The surface is being resurfaced. There's mountains of water ice as tall as the Rockies, because at Pluto's temperatures, water ice is hard as rock. A thin blue-tinged nitrogen atmosphere with layers of haze, and a real possibility of a liquid water ocean sloshing beneath the crust.
A subsurface ocean, on a world people were arguing wasn't important enough to be a planet.
Which is the poetry of it, isn't it? The label we hang on Pluto changed nothing about Pluto. It's exactly as fascinating as the day before the vote. And it's not alone out there. It has 5 moons of its own. The big one, Charon, so large that the 2 of them orbit a point in empty space between them, like a slow cosmic waltz.
So tonight, when it's at its brightest and best place for the year, that faint 15th magnitude dot in Capricornus is a churning, hazy, possibly ocean-bearing world with a heart on its face.
That's the one. And whatever you want to call it, planet, dwarf planet, Kuiper Belt object, tonight is Pluto's night. We'll tell you exactly where to point a scope in the Skywatch. Clyde Tombaugh, by the way, passed away in 1997, and New Horizons carried a small portion of his ashes on that flyby. He got to visit the world he found.
Okay, I'm not crying, you're crying. Let's bring it back to Earth. Literally. Speaking of coming home, 3 people did exactly that yesterday. On Sunday, a Soyuz MS-28 capsule parachuted down onto the steppe of Kazakhstan, bringing NASA astronaut Chris Williams and Roscosmos cosmonauts Sergei Kuzverchkov and Sergei Mikhaev back after 241 days aboard the International Space Station.
241 days. Put a number on what that actually is.
Nearly 8 months, around 3,885 laps of the Earth, and more than 102 million miles traveled, all while effectively standing still in orbit. They launched back on the 27th of November, American Thanksgiving, so they've missed an entire summer and winter depending on your hemisphere.
And it was a first flight for 2 of them.
It was. First mission for Williams and for Mikhaev. Kuzverchkov's the veteran. He's now past 425 days in space across 2 flights. And I want to flag the quiet significance here. A NASA astronaut and 2 Russian cosmonauts riding home together in a Russian capsule. Whatever the politics on the ground, the crude side of this partnership just keeps functioning, seat swaps and all.
What was Williams actually doing up there? It's easy to forget these are working science missions, not just endurance feats.
Right, and his work is genuinely down to earth in its aims. He supported research into novel cancer therapies, which benefit from the way proteins and cells behave in microgravity, and into manufacturing high-performance materials, the kind used in advanced electronics and computing that you can make more cleanly without gravity pulling everything around. The pair of cosmonauts also did a spacewalk back in May to install a solar radiation instrument on the station's exterior.
And the handover keeps the station rolling.
Seamlessly. Command passed to NASA's Jessica Meyer as Expedition 74 became 75, and a fresh crew, Anil Menon and 2 cosmonauts, arrived earlier this month to keep the lab staffed. The hard part now, ironically, is gravity. After 8 months, just holding your own head up is exhausting. The readjustment takes weeks.
Welcome home to the 3 of them. Now, from people orbiting one planet to the most common kind of planet in the entire galaxy.
Moving on to Story 3, Sub-Neptunes, clouds of rock, oceans of magma. What's this all about?
Here's a fact that still catches me out. The most common type of planet in the Milky Way is a type we don't have. It's the Sub-Neptune, bigger than Earth, smaller than Neptune. There's nothing like it in our solar system, yet they turn up everywhere else. Out of more than 6,000 confirmed exoplanets, well over 2,000 are Sub-Neptunes.
And we barely understand what they're made of.
That's the frustration. They could be small rocky cores wrapped in thick hydrogen atmospheres, or they could be water worlds, volatile rich, drowning in water and carbon molecules. And we can't easily tell because even the James Webb Telescope can only read the very top of the atmosphere, and these atmospheres are deep and hazy. New modeling from a team at Arizona State, recently published, offers a clever way through, and it puts clouds at the center of the story.
Clouds. On a planet where weather must mean something wild.
Wild is the word. Deep down, where the pressure is crushing, the team modeled clouds made of vaporized rock and salt. Think aluminum oxide, iron, silicates, potassium chloride, actual mineral clouds. And here's the key finding. Those clouds act like a blanket. They trap heat trying to escape from the interior, which pushes the boundary between the atmosphere and the solid body to temperatures high enough to melt rock.
So beneath the clouds, you might have an ocean of magma.
A global magma ocean in the cloudy scenario. In the cloud-free version, that boundary is cooler and might stay solid. Same planet from the outside, 2 completely different interiors depending on the clouds. And that matters for us for a very practical reason. It changes how we interpret what Webb sees, and it feeds directly into which of these worlds we bother calling potentially habitable.
To be fair, this is modeling, not a direct observation.
Completely fair. This is simulation work pointing observers at what to look for, not a photograph of magma. But it reframes clouds from being just an annoying smudge that ruins our data into an active ingredient shaping the whole planet. For the galaxy's most common world, that's a meaningful shift.
From world we're modeling to a monster we've actually photographed. Let's go to M87.
Next up, Story 4, a sharper look at M87's black hole.
Cast your mind back to 2019, that first ever image of a black hole, the orange donut. That was M87, the supermassive black hole at the heart of a giant galaxy in Virgo, about 55 million light years away, weighing in at around 6.5 billion suns. That single image was one of the defining science pictures of the decade.
And now a team has gone back to the data and done something new with it.
That you have. Researchers led by the Shanghai Astronomical Observatory with international collaborators have produced the first spatially resolved dual-frequency spectral map of M87. And I know that's a mouthful, so let me unpack it because it's clever.
Please, dual-frequency spectral map needs a translation.
Think of it like this. The 2019 picture was a single-color photo of the ring. What this team did was image the black hole at 2 different radio wavelengths, 1.3 millimeters and 3.5 millimeters, using the Event Horizon Telescope and a partner network called the GMVA from observations back in 2018. Then they compared them point by point to see how the color of the glow changes as you move outward from the center. That comparison is the spectral index, and mapping it across the ring had never been done before.
And what did the map show?
A clear structure. The signal is one character inside the bright ring, and it steepens, changes flavor, as you move outward, with the transition landing right at the ring itself, about 30 microarc seconds out. And that's the headline. It tells us the ring we photographed in 2019 isn't just a trick of where the light happens to glow. It's tied to a real physical change in the plasma right around the event horizon.
So why does that matter beyond nice, a sharper map?
Because reading a black hole means untangling two things that are mixed together: the pure warping of space by gravity and the messy physics of superheated plasma spiraling in. The researchers say looking at multiple wavelengths lets them start to separate those two. That's the path to understanding how these monsters feed, how they fire off those enormous jets, and eventually to a cleaner test of Einstein's general relativity. It's the difference between having a portrait and starting to read the biography.
A portrait to a biography. I'll take that. And on that note, let's step outside, because it's Skywatch time. And as always, wherever you are on the planet, we've got you. Avery, you take the south, I'll take the north, and we'll meet in the middle at Pluto.
Deal. Southern Hemisphere first. And friends down south, this is your week. The Southern Delta Aquariids are peaking. This is a shower that genuinely favors the south. The radiant in Aquarius climbs high after midnight for you, and under a dark sky, you could see something like 20 to 25 meteors an hour. No equipment, just a reclining chair, a wide open view, and some patience while your eyes adapt.
And there's a comet for the early risers.
There is Comet 10P/Tempel 1 low in the pre-dawn sky. It's a binocular or small telescope object rather than a naked eye showpiece. But here's a southern bonus. It's diving southward through August, so our southern hemisphere listeners get the better and improving view. Northern folks, catch it now before it drops away from you.
Northern Hemisphere, your headline is a star with a wonderful name. Look high toward the north for the constellation Cepheus. It looks like a child's drawing of a house. And near the bottom of that house sits Mu Cephei, better known as Herschel's Garnet Star. It's one of the reddest stars you can see with the naked eye. A bloated red supergiant so vast that if you dropped it where the sun is, its surface would swallow Jupiter. Binoculars really bring out that deep ember color. And you northern observers get the Delta Aquariids too, just lower down toward your southern horizon.
And now, the meeting point, the one we teased at the top, Pluto.
Pluto's at opposition tonight, over in Capricornus, which is beautifully placed for the southern hemisphere, high overhead, and perfectly workable low to mid-northern skies too. Now, the honest part, at magnitude 15, this is a genuine challenge. You'll want at least an 8-inch telescope, a detailed finder chart, and the trick is patience. Sketch or photograph the star field 2 or 3 nights running and watch for the one star that moves. That mover is Pluto. It is the ultimate bragging rights target.
And there's a catch tonight for everyone.
There is a big, bright moon, about 95% full, washing out the sky all week. That won't bother the Garnet Star or the brighter meteors much, but it makes faint Pluto even harder. If chasing Pluto is your goal, wait for it to clear the worst of the moonlight, or give it a week. Oh, and Saturn is rising after midnight over in Pisces for both hemispheres, rings and all, a lovely consolation prize in any scope.
North or south, there's something up there for you tonight.
And that's Astronomy Daily for Monday, the 27th of July. A faint little world having its big night, a crew safely home, magma oceans on the galaxy's commonest planet, and a sharper look at the first black hole we ever photographed.
You can find show notes, links, and every past episode at astronomydaily.io. And the observant amongst you will notice that we have a brand new website today, so make sure you check it out. And we're at Astro Daily Pod across social. If tonight's Pluto story settled or restarted an argument in your house, we'd love to hear it.
For Avery, I'm Anna. Whatever you decide to call Pluto.
Clear skies.